Hello everyone and welcome back to Nothing New. Today we'll be going over Leetcode problem number 9, palindrome number. So here's a table of contents. First we're going to be understanding the problem, then the algorithm, and then implementing the algorithm, testing the algorithm, and analyzing the algorithm. So first we're going to be analyzing the problem. What is it asking? So the problem states, given an integer x, return true if x is a palindrome integer. An integer is a palindrome when it reads the same backward as forward. For example, 121 is a palindrome while 123 is not. So let's break down the problem. For the input, we're given an integer x, and we need to output a Boolean value, which is a true or false value. And what we need to do is to check if the number is a palindrome. And a palindrome, as stated in the problem, is a word, phrase, or sequence that reads the same backward as forward. So here are some examples given by the problem. 121 would be a palindrome because if you read it backward, it's still 121. However, negative 121 is not. If you read it backward, it becomes 121 minus. And 10 is not a palindrome because if you read it backward, it would be 0, 1. Alright, so here's how you would do it manually. You would first read the input, reverse the input, and compare. If they were the same, it's a palindrome. Otherwise, it's not. So 1, 2, 3, 4, 4, 3, 2, 1 backwards is still 1, 2, 3, 4, 4, 3, 2, 1. So the input is a palindrome. However, 1, 2, 3, 4, 5, 6 backward is 6, 5, 4, 3, 2, 1, and they are not the same. So the input is not a palindrome. So after doing this, your initial thought might be to reverse the input and then compare when you're coding the problem. However, we'll find that there's a better way to do it. Alright, now we're going to be learning the algorithm. How do we solve this problem? So we're going to be using a two-pointer algorithm instead of reversing and then comparing. So we have two pointers I and j, initialize I at the start and j at the end of the input. Then we simultaneously move the pointers towards each other. So we move I to the left and j to the right. And for each iteration, check if the current character that the pointers are pointing to are equal. If they're not, then the number is not a palindrome and we have to return false. However, you can't iterate through an integer in Python. So we have to convert the integer to a string. Here's the algorithm in action. This is a positive example, meaning that this number is a palindrome. So this is the first iteration, and you have I and j at their supposed directions. And we move on to the next iteration and shift I and j. 2 is equal to 2, and we continue comparing. 2 is 2 equal to 2, 5 is equal to 5, 3 is equal to 3. So we've reached end, and every single number we've compared are equal. This means that this number is a palindrome, and we can return true. Now we're moving to a negative example. This number is not a palindrome, and we'll see why. So we have I and j. We compare I and j. They are equal. I and j are still equal. I and j are equal. I and j equal. Oh no, 3 is not equal to 5. This means that this number is not a palindrome, and we can return false. Alright, so now we're going to be implementing the algorithm. We're going to be coding it up in Python. And so, here's the pseudocode. We define and set out first, convert x to a new string, new input equals string input. We don't want to modify the original input, because it is very important that we have a copy of it saved so that later when we want to use it, it's there. Define I and j at the start and end. Note for j, I make it length of input minus 1 because indices are 0 indexed. And we use a while loop to iterate through the input. The loop definition is while I is less than or equal to j. As seen in a previous example, I and j can overlap. We use an if statement to check if I and j's values are equal. If they're not equal, we return false. And we increment I, decrement j. If we reach the end, exited the loop, and the function still hasn't returned false, then the number is a palindrome. We return true. Alright, now we're going to be testing the algorithm. We're going to be running and submitting it on Leetcode. So let's go over to Leetcode. Alright, so first we want to convert x to a string, and we're going to do that with a separate variable because we don't want to modify the input. And then after that, I equals 0, j equals length of the input minus 1. Alright, Now we have finished our setup. Let's move to the while loop. While I is less than or equal to j, we compare if num I is not equal to num j, then we immediately return false. We don't let the loop continue. And then increment I, decrement j. And then after all that's finished, we can return true. Alright, so we're going to be testing it. So the first test case works, and we have passed. Alright. Now we're going to be analyzing the algorithm. Why is this algorithm better than the reverse and compare one I mentioned at the start of the video? Okay, so first we'll do a time and space complexity analysis. The time complexity of this algorithm is O of n, where n is the length of the input x. We converted the input to a string, that's an ON operation. We scanned through the input with 2 pointers, that's another ON operation. 2 steps equals 2 times ON, which equals ON. Space complexity is also O of n, where n is the length of the input x. We converted the input once using linear extra space. Alright, now we're going to do an algorithm comparison. So looking at the reversing the input algorithm, we'd have to do 3 steps. First, convert input to a string. Second, reverse the input. And third, compare the 2 inputs. This costs a lot of more time. And also it uses double the space since we have to keep 1 converted input and 1 reversed input. Now looking at our 2 pointers algorithm, there's only 2 steps. We convert the input to a string and iterate through the input with pointers. And it uses less space since we only need 1 copy of the input as a string. Alright, here are some common mistakes that you want to avoid when doing problems like this. So first is messing up on loop definitions. Make sure it's while I is less than or equal to j, or else the loop would stop early in some cases. This caveat is very common when doing binary search problems. And second, not immediately returning false after finding a difference. The loop would continue even though we already know the input is not a palindrome, resulting in a wrong answer. Alright, I hope you learned something new in this video. If you have any questions, concerns, or comments, please comment down below. And if you like this video, please like and subscribe. And I'll see you next time. Bye.